So want to welcome everybody to our first Steam Timber webinar for 2017. I think this is our third September now where we've kind of decided to shift our focus and kind of devote the whole month and all of our webinars and newsletter information and so forth to everything to do with Steam. So we appreciate you having an interest in that and being with us. We're also happy to have Kelly Paffel with us, who's going to be talking through why standard operating procedures are necessary for steam trap inspections. So it's always good to hear from Kelly, and he's always got great information. So we're looking forward to what he has to say here in just a couple moments. So just a little bit of housekeeping before I turn things over to Kelly. I am recording this, so if you have to hop off early or you've got colleagues who you want to have listen to this information, we will have that available up on our website. Most likely later this afternoon, I'll be able to pop that up there, so you'll be able to check that out. And also, we do have the ability for you to ask questions. There's a little questions box that you can type in any questions you might have throughout the webinar, and I'll get those over to Kelly throughout the session. And then, of course, at the end, we'll have time for Q&A as well. So definitely take advantage of that. And you know, again, as you saw from the beginning, if we do have any technical issues throughout, we'll try and get them fixed as quick as we can. That's just part of doing these things live, but we think there's value in it, so that's how we're going to keep doing them. So anyhow, with that, I am going to turn the screen over to Kelly. And Kelly, welcome, and we'll let you take it away.
Very good, thank you. My name, again, is Kelly Paffel. I'm Technical Manager for Endino Engineering, LLC. We're located in Tampa, Florida. Today I'm going to be talking about why is it necessary to have a standard operating procedure, or what's abbreviated called SOP, for steam trap station testing and assessment. So the question comes up is, why have a standard operating procedure? What is a procedure? It's to set forth the requirements necessary to safely and successfully complete a steam trap station assessment at the plant. So the procedure is that we can have people go out and conduct a steam trap testing assessment and have it repeat to be accurate every time. Without an SOP, how do we know each test will be done correctly? You know, do we just assume the person knows what they're doing? Do we assume the person is doing the procedure correctly? The thing is that we can't assume, then we will not get repeatability. So that's the reason for an SOP. The other big advantage for having an SOP is, how do we train people in the future for doing the testing? How do we pass down this knowledge? Once a SOP is developed, it's always a continuing developing document, meaning that the person that's in control of the document or people are continuing to add to it or improve it. So the thing with having new people come on, they'll have a document to follow to make sure that they're doing the test correctly and repeating each test. An example would be, when I go onto an airplane, a pilot's been there for 25 years flying the airplane. And if you look in the cockpit when you're getting on the airplane, what's he doing? He's going down his checklist or his SOP to make sure that he can get the plane up in the air safely. So SOPs is used in all types of industries to make sure that the product is produced repeatedly and accurately, and a quality standard is maintained. It's the same thing when we're doing steam trap testing. The other thing for plant operations, if I'm going to hire an outside firm, how do I evaluate the outside firm that's doing the steam trap assessment? Do I evaluate them just because they have an ultrasonic unit or a temperature measurement? Or they've been doing it for 10 years? The thing is that when I evaluate people coming on site to do work for me on testing, be non-destructive, I'm looking at their qualifications, but I'm also looking for their SOP or their procedure documents. If I look at a company's SOP for steam trap assessment or testing, and it's 2 paragraphs, that tells me one thing. If I look at their SOP and it's 56 pages long, then that tells me something else. So the thing is that which company do you hire? The one that has 2 paragraphs or one that has a document of 56 pages? The thing is that the SOP that we follow with our staff is 56 pages in length. So we go through everything to make sure that our staff members are doing the testing correctly and repeatedly. So the SOP will provide an indication of how the company will check their staff performance. As I go out and supervising or managing a steam trap assessment, I can go and check their qualifications or quality control check by see how they're performing per the SOP. So it provides a lot of different value aspects. One of the things the SOP goes through is when you're going to do a steam trap assessment, how, who gets involved? Because everyone gets involved. The plant management, purchasing, engineering, maintenance, and operation. Everyone needs to be involved. Just having one person involved is not good enough. So the thing is that everyone needs to be involved. And that's part of the SOP is who do I communicate to that this is going to occur? Who needs to be involved? Well, everyone, the plant management, purchasing, engineering, maintenance, and operation. Some of the other things that need to be included in the SOP is define the team, SEAL members. Who's going to be doing this? Do I send one person out? Sending one person out, it's very difficult to do any steam trap assessment with one person. So we set up what we call the team, which is the testing person. And that testing person is using ultrasound and infrared and tagging and locating, and another person for data collection. The thing is that to go out and just do testing without collecting data, it's not going to be a successful assessment. So we're looking at a combination of people. And then there's also support people. The support people are possibly the people that are putting the information into the software system that we're collecting the data in. So we define the team members, who's all going to be in the team. The other thing that's very important is what's the requirements for PPE, personal protection equipment. Of course, normal is hard hat, safety glasses, hearing protection, long sleeve shirts. In a lot of cases, we're using Nomex. And Nomex is a fire retardant coveralls. So we define out in the SOP for the PPE equipment. And we're also looking at maybe there's other PPE equipment that might be required. Goggles, face shields, high temperature sleeves. So those are the other items that we always put into the SOP. Safety review for the team members, areas that are going to be accessed. Do we need to check into the control room? Do we need to sign in? Do we need to put our names onto the board so that they know that we're there? And then we have a job risk assessment. Now, some plants have their own forms that they do for a job risk assessment. If they don't, we do our own form so that we do a job risk assessment for all the team members. So we're identifying the risk that might be out there. And the SOP kind of goes through the guidelines that we want to see put their information put onto the risk assessment. So steam trap station testing, again, other devices that might be required, gas monitoring, what types that we might need, H2S monitors or anything else, bump testing the monitors, who's going to do that? We're going to do it at the plant, where is the bump testing going to be done? And then we get into types of lifts, ladders, and other methods to reach a steam trap station higher elevations. So the SOP will go through, all right, if we're going to use lift ladders, okay, who's qualified to operate? Because that's part of the SOP. And what type of safety harness do they have to have? Or is the plant going to provide the safety harness? And that's all part of the SOP. getting prepped for the steam trap assessment. So then it goes into the equipment. Of course, flashlights is a necessity. And one of the things with the flashlight is intrinsically safe. A lot of the locations that we go into, we have to have intrinsically safe equipment. So we're looking at making sure our flashlight devices are intrinsically safe. What unit am I going to be using? Am I going to be using a UE 9000, 10,000, or 15,000? If I'm going to use a UE 9000, when's the last time it was calibrated, and do I have the calibration documentation? The stethoscope module, one of the things in the SOP is to make sure the stethoscope module is calibrated to that unit. And do we have extensions? Do we need more extensions? So it continues on the equipment that we're going to use. And there's other accessories. The umbilical cord for the stethoscope module can be used. And we might use a painter's extension rod to get up at higher locations. But again, that's listed out in our SOP. Our infrared units, again, we want the calibration documents. We want to know the target area so that people will know that they're using X units, that the target area is going to be X diameter at this distance. So when they're taking temperature measurements, that they know what their target area is. The other thing that in the infrared units is setting up the emissivity. So there's an emissivity check to make sure the unit is set correctly. One of the most critical things is this holster and other pockets. So we've got to carry this equipment now. How do we safely carry the equipment on into our plant to do the steam trap assessment? And the SOP lays out the devices that we have, holsters, and other pockets depending on the team member and what they're going to be doing. One of the things that we found that is going and purchasing a utility belt that's very wide is more comfortable with holding the holster and the other equipment in a normal day-long steam trap assessment out in the field. So those all are laid out into our SOP. Again, equipment, clipboard, how to identify the steam trap location. We're going to do assessment. How we need to understand how do we get the people that is going to do the repair, replacement. How do we get them back to that location? One of the things is that we're going to tag. There are certain tags that are acceptable, certain tags are not. So we identify what tags are going to be used and how we're going to secure the tag to the steam trap. Typically that's done with a wire or chain method. The other thing that's used today is pictures of locations. So identify the steam trap, and the SOP goes through, okay, the picture will be taken. This is the numbering sequence. This is how to put the picture into the correct file for access to link it with the steam trap identification number. So that's laid out. Data logging, what format? Are we going to put the information to Excel? Are we going to put the information to SAP or the plant maintenance system at the plant? How do we gather this information, and what do we do with the information? Once that we have gathered the information in the plant, we need it to put in some type of software system so we can pull it up each time that we're going to go back out and do the steam trap assessment. Information. What information is required? Location, of course, manufacturer, model number, connection size, connection type, internal orifice diameter of the steam trap, the operating pressure, and then continues on. We list out, downstream pressure, what type of condensate return system that's the steam trap discharging into, how to evaluate the inlet pressure to the steam trap if it's on a modulating system. Again, it goes into depth telling the people, team members, how to gather each piece of information so we get accurate information. What to do with the data? We have handwritten sheets that typically we've done in the field. We've done with data loggers out in the field. We bring in this information. I was kind of briefly talking about this before. We then put it into Excel. or do we input it into Microsoft Access, or the plant a PM system or SAP system? But we have to do something with the data, and how do we evaluate one assessment versus the next assessment so we can find issues with steam trap stations that are repeatedly failing out there in the plant. Before starting is, in the SOP kind of goes through, make sure that the people understand that before getting started, if we find failed steam trap stations, and we always say stations, not a steam trap, because steam trap stations are made up on isolation valves, strainers, blowdown valves, and could be double blocking and bleed valves. It depends on the plant requirements, but make sure the plant or yourself has a standard for replacement of the failed steam traps. Go in and do a steam trap assessment without having a roadmap or documentation of what a replacement steam trap station should look at. The diagram here is a double block and bleed valve, so we can work on the steam traps with the steam line in operation. All steam traps need to have a strainer, and the SOP kind of goes through guidelines on 20 mesh strainer for a steam trap, and the steam trap testing assessment group will have somebody that's capable of opening a valve, which is the blowdown valve on the strainer, and blowing down the strainer, make sure it's clean and in good operating condition. But that's one of the other things. In the SOP, we outline the meetings. We always want to have a pre-meeting with everyone to kind of lay out the objectives and the target areas that we're going to be doing the assessment then, and then follow up by daily meetings. Daily meetings are what we covered the previous day and what we're going to cover that day and what we might need for plant personnel involvement. May it be production people getting involved with us, and maybe power people getting involved. But those daily meetings are very important, and we have them detailed what we want to cover in the SOP. And then, of course, post-meeting, once we're concluded, is having a post-meeting with all the team members that were involved in the plant to go through, and this is what we found, and these are some of the highlights of the assessment, which was followed up by a full report, again, which is outlined in the SOP. So SOP kind of goes through the meetings. The SOP steam trap session will go through the steam trap testing, which is the methods, visual, temperature, and ultrasound. And the comment I always get people to ask me is, what's the best method? And I always tell them using all tools available, visual, temperature, and ultrasound. And each method needs to be detailed in the SOP. And people ask me, visual, what do you mean visual? Okay, visual is installations. So when I go into a plant, I'm looking at steam trap stations, 10% of the steam trap population is installed incorrectly. I've multitude of times find steam traps are installed backwards, upside down, not in the correct position. The other thing that we're looking for is the correct materials for the steam pressures. In steam systems, we're underneath the code B31.1, which is the National Power Piping Code. Too many times we find the steam traps do not have the pressure rating or the correct materials for the operating pressure of the steam system. That's a code violation. So visual tells us, that the correct materials are for the pressures that we're operating at. And discharge, is it open to atmosphere? If it's open to atmosphere, then you can visually see if the steam trap is working properly or not by the discharge to atmosphere. So visual testing is very important. The other thing is, as you can see in the picture here, the steam trap discharging. And one of the things you have to detail to the team members is, when I'm going to do visual testing as this steam trap is discharging to atmosphere, is understanding the higher pressure, the more flash steam that's going to be generated. So this steam trap here is generating a lot of flash steam because it's operating at higher pressure. As I go down in lower pressures, there'll be less flash steam generated. And why that's important is we want to be able, the team members, to understand if the steam trap is discharging flash steam or is it blowing steam through during its cycle process. So we kind of detail that out, and it takes experience, of course, but the more you do it, the more proficient you get at it. So visually testing a steam trap is very good. If the steam trap's blowing through, everyone can visually tell that. It's visually testing and with normal operation, determining what's the difference between flash steam and leaky steam. The next is, on the left side, there's a visual indicator. And this visual indicator is looking at flow coming down. And the glass should be about half steam flow to the steam trap and half condensate flow going down to it. Visual is very important when it comes to checking process steam traps, just understanding the evacuation process. On the right side is a visual indicator of a steam trap. Different countries, I go down to South America, the steam trap with the visual indicator is quite common. And North America is not common to find this type of a steam trap with a sight glass into it. So the steam trap level is where the red mark is showing there. There's where the level is. And you can see the modulation of the steam trap as it's operating. So it's a very good test method, but it's also associated costs with it. And the other thing has the pressure rating of the glass. So there's positives and negatives to everything. So you have to weigh, cost is, a negative, but does it give you a indication of condensate drainage? Could be the positive, which outweighs the negative, which is cost. The next is temperature testing, and I briefly mentioned it is about emissivity, making sure the emissivity and the SOP goes through, and there's a procedure that's outlined in the SOP to check the emissivity and target area. So as you go up in cost with infrared units, the target area gets smaller because the optics is much better. The SOP also needs out to align the different testing procedures. The thing with the testing procedure is that inlet temperature equals the steam trap temperature. The steam pressure at 150 psi, it should be 366 degrees for the steam trap temperature. In this example is a modulating steam to a process application, and the temperature after the control valve is 299 degrees Fahrenheit, and the SOPs gives them, some training methods for checking temperatures, and that steam trap is 293 degrees Fahrenheit. So the inlet temperature of the process and the steam trap temperature should be pretty close or equal. So again, we have examples in our SOP kind of described so the team members can go back and reference to it or brief themselves on the temperature testing methods. The next is going through the settings of the ultrasonic unit, what kilohertz setting that we should be setting the units up for, understanding briefly how to adjust the sensitivity of the ultrasonic units and the operation of the different types of steam traps and the ultrasounds that will be emitted from the different types of steam traps. This is very detailed because there's three major different groups of steam traps, which are mechanical, thermodynamic, and thermostatic. And we have to make sure that the people understand the testing procedures for each one of those three groups of steam traps. So the SOP outlines how we move forward after the actual assessment is completed and priorities that we set up. So the thing is that we're going to go out, we find 150 steam traps. Well, I'm not going to go out and fix all 150 steam traps instantaneously, so I want to set up priority levels. Which are the steam traps are causing me the most problems? That's priority 1s, and then 2s, and then 3s, and sometimes I set up priority 5s. The other thing is that once we determine failure, is how do we eliminate failures? So part of the SOP is determine the component failures, but also to eliminate failure. On any steam trap assessment, the goal of the steam trap assessment is to have a failure rate of 3% or less of the steam trap population. So when I go out and do a steam trap assessment, I don't want to see 12% failure rate or 10% failure rate. I want to see a 3% failure rate or less. But to eliminate failure, you have to understand what caused failure. And that's a very, very important aspect of it. So the thing is that root cause analysis becomes a very critical part. To perform the test, the SOP needs to lay out how many test points are required to perform the test. On the lower left-hand side, there's a test 1 upstream, test 2 downstream, and test 3 downstream, as close as possible to the discharge orifice of the steam trap. That's where you're going to find the highest degree of ultrasound generated, is downstream of the discharge orifice of the steam trap. And the thing is, why do we take upstream, downstream, is to make sure that we're not picking up competing ultrasound that possibly could be in the system. Now, if you look on the right side, there's a multitude of different test points. Test point 1, 2, 3, 4, and 5. And it's not limited to 3. You can use up to 5 test points, or you can use 8 test points. But you need to do test points and make sure that you're not picking up competing ultrasound. One thing I find with the testing teams is that they come and they say, well, we're picking up this sharp rattling sound in the steam trap. It's not that. It's the check valve downstream of the steam trap. And that's why we use multiple ultrasound readings upstream and downstream to find competing ultrasound. So it's very critical to use a comparison method, and that's outlined in the SOP. The other thing we define is what's the test results going to be? What's, proper operation, blowing completely failed, leaking steam. One of the things is that not in service. You have to define this in 2 ways. Non-service, steam trap station valves are closed. The steam trap should be in operation. Steam trap is critical to the steam system. One of the things that fine is walking into plants and they turn off steam line, drip leg steam traps. And they say, why did you turn it on? That was failed. But shutting it off is not a solution. And that's creating an even greater problem, because one of the things is that steam trap is designed to drain out the condensate in the steam line during operation. And if you do not drain that, you can get severe water hammer. It's not uncommon for steam systems to have explosions due to water hammer because somebody shut off a main steam line trap. So when I go and look at, reports from assessments, and they have it not in service, but they don't tell me it should be in service, or it was on, the next one, not in service, is the second, is process is not in operation, non-critical to the steam system. So here I go by and the shell and tube heat exchanger is not being used because they're not running that product. That's fine. That can be put in not in service. So you need to define, how you're going to label the steam traps. And it's a common problem I find this not in service, and defining that these steam traps should be in service. So anyway, cold, steam trap is plugged, check valve is filled shut, steam trap's filled in the cold position. Just another way of describing, the fail component. The other thing that goes through on the SOP is the different configurations of steam traps, and we have more. I'm just giving a brief example of them right here. And where to place the stethoscope module when you're testing for the steam trap, because again, I want to be downstream of the discharge orifice. That's where I'm going to pick up the highest degree of ultrasound that's going to be generated, and that's where I want to be testing in. So we go through and show, and the team should be carrying a sample of the diagrams like this with them, so when they walk up to a steam trap, they can identify it as inverted bucket mechanical, flow thermostatic, thermodynamic thermostatic, bimetallic thermostatic, or Bose thermostatic, so they understand what type of steam trap they have and where they should be putting the stethoscope module. Two types of operation when we go into steam traps is one is on-off operation. So when I'm going up to the tests, the SOP will define, okay, it's inverted bucket thermostatic and thermodynamic. And it goes in and defines what the ultrasonic readings are going to be for the inverted bucket, what the ultrasonic readings are going to be for the thermostatic, and what are the ultrasonic readings going to be for the thermodynamic, how they perform. And thermodynamic is a very fast-acting on-off operation, and a bellows thermostatic is a very slow on-off operation. But the SOP will go define the two types of operation and what the ultrasonic readings are going to be for each steam traps. So they have this document, and they can take the document with them, and they're in question what the reading is telling them. They can go back to the SOP and check and see what the dynamics of that type of steam trap should be with ultrasonic readings. The other one is a continuous flow type steam trap, which is probably a little bit more difficult than the other type of steam trap to do testing, because there's two different testing points on the steam trap. One is the main discharge orifice, which is located at the bottom of this diagram. And the other one's the air venting mechanism, which is located up above it. And the SOP goes through how to test both of those discharge orifices and to understand the performance of each one during operation, startup, and in failure mode. So the SOP not only goes through what the steam trap, ultrasonic readings, temperature measurements should be during good operation procedure, but also in the failures. If it's leaking, these are the readings you're going to get. If it's blowing, these are the ultrasonic readings that you're going to achieve. So not only on the proper operation, you have to have the SOP go through and define the ultrasonic readings for leakage, blowing, steam, and this we have to go through on two different orifices what those readings would be. So the SOP will define each one. So conducting the tests and inverted buckets on-off, and on here it's a UE 9000, and the steam trap is in the off position. You see deflection to, up on the meter, and when it discharges, it comes back down. And people say, where do I set the sensitivity? The sensitivity is set based on your comparison test points. That's critical, because I can set up the sensitivity and make all your steam traps good, or I can set up the sensitivity and make all your steam traps fail. So it's understanding where to set that sensitivity, and the SOP goes through that and defines that. It's in 3 pages long of defining that sensitivity and how to set it up, because we want accurate measurements. We want testing to be 99% accurate, and that goes through there. So I just briefly said it before, the SOP needs to review each of the failure modes and how the failure mode will be detected. Here is an inverted bucket that the lever mechanism failed, detached, and it's blowing steam through, and the indication on the meter will be, high level readings, steady, no on-off operation. So the SOP needs to define, again, not only good operating steam traps, but also steam traps that are in the different failure modes. The next is on root cause analysis. Is part of the SOP is take the steam trap apart, visually, inspect the steam trap after it's been detected into a failure mode, and how to document the failure. So, and the correction method for the failure. So not only what failure occurred, but the changes that need to occur to prevent further failures with the steam trap station. So that's all defined in the SOP, and root cause analysis has to be done with each steam trap that's in the failure mode, so we understand what caused the failure and institute change into the operation to prevent any further failure. The steam trap station assessment failure, steam assessment, testing failures all the time. One of them is no SOP is developed or implemented, therefore there's no training, no tools, no documentation. So if you don't have the training, tools, or documentation, there's no reason to start. Early in my career, I worked night shift in the power operations, get myself through school, and they decided to have me go and test steam traps. So I'm out testing. They give me an ultrasonic unit, no training, and it said read the instruction manual. I go out. I didn't even know what a steam trap was. So how proficient or how accurate was my testing going to be? Very, very poor, extremely poor. So no training. And the tool I was using wasn't that great of a tool, and I was told not to do any documentation. So what was the reason for I was to be out there? Just to do it? So the thing is that that's the key thing for a successful program, is to have a well-documented SOP. So kind of SOP, and I always tell people today is a great day to get started. Maybe tomorrow, okay? But we have to get started. And how to get started is start to develop an SOP. And the thing is that if you have questions or whatever, here's my contact information. Please contact me. Let me help you, achieve a correct SOP so you get an accurate, test assessment of 99.9%. And I think that can be achieved. So thank you for your time today. And I'll turn it back over to you, Marie.
All right, awesome. Yeah, we definitely want to avoid people just being handed a piece of equipment and say, here, go, do, and have no understanding or reporting back. So this was really good information. So definitely, if anybody has questions, as you see, he's got his contact info there. But if you want to type those in, so everyone can benefit from the questions you've got. I did have a couple come in already though, so we'll toss those over to you now. So someone was wondering how you get the orifice size if there's no nameplate on the steam trap.
Wow, great question. The only way is to take the steam trap apart and check the diameter of the orifice with a measurement device. That's a difficult one. And the thing about it is that when you're purchasing steam traps, make sure you have the steam trap is well documented on the body of the steam trap of what orifice is inside that steam trap, because some of the steam traps, specifically, are very sensitive to pressure ratings of the orifice. If you exceed the pressure rating of the orifice, the steam trap will come into the off position and stay off and could generate severe water hammer.
All right. And then let's see, what's a good rule of thumb for how often an inverted bucket trap cycle? I'm eating my words here.
No problem. A rule of thumb, 15 seconds in the off cycle. So if it cycles faster than 15 seconds, it's undersized. So inverted bucket, should cycle no faster than 15 seconds. Now, an inverted bucket can stay off for 15 minutes. One of the things, when it's staying in the off position for a long period of time, it can lose prime. So you have to be a little bit careful with oversizing an inverted bucket. But more so, people, I find undersizing more of a bigger problem. So you want it to be in the off cycle for 15 seconds.
All right, awesome. Okay, well, that's all the questions that so far have come through. So maybe everybody's already starting working on their procedure. Oh, wait, here we go. Someone just typed in, how often is thermostatic cycle?
Well, a thermostatic steam trap is similar to the inverted bucket. We do not want it to be cycling fast because that means the steam trap is oversized, not undersized, oversized. We call that short cycling. And that will limit the longevity of the thermostatic bellows or bimetal configuration. So we want the thermostatic trap to be off, so 25 to 30 seconds for a rule of thumb, cycle, and then be off again for 25 to 30 seconds.
All right, now we've got the cycle questions going. So someone now is asking about how often for a disc trap, what the cycle is on that.
12 seconds or less, we consider the steam trap to be in a failure mode, which is going into what's called machine gunning, this term, a rapid cycle. And in a disc type or thermodynamic design, there is a steam loss when it starts to do the fast cycling. So that time period we consider to be in a failure mode. It'll fail shortly, but we consider it a failure mode.
All right, cool. Well, let's see. Oh, how often is testing needed for steam traps for cost savings? Or is that kind of up in the air?
The steam trap testing is that you have to define in the system which steam traps, if in the failure mode, are going to cost you energy. And the thing is, people say, a 200 psi steam trap is going to cost me $15,000 a year. It depends on where the 200 psi steam trap is discharging. If it's discharging into a flash system, it's not really costing anything except the mechanical energy if you're using a turbine for pressure reduction. So you really have to define in the plant which steam traps, if in the failure mode, are costing you energy. And the second thing is if it's going to cause you a system operation. One of the things when you start a steam trap assessment program and is the failure rate is 25%, then you should be doing it every month and to find out where the failure is occurring and how fast they're occurring. Once you get to a 3% failure rate, then we go and define how often we test steam traps by other measurements. One of it's doing pressure readings on condensate lines. The condensate line with all the steam traps working correctly is at 3 psi, and if that pressure increases to 5 psi, then we know we have steam trap failures out there, which are pushing in live steam into the condensate return system, creating pressure. So there's indicators that we put into the system that tells us when we should be testing steam traps.
All right, now people have got the juices flowing. So let's see, someone's asking about kind of temperature. So they said we have failure on thermostatic in the cold weather around minus 23 degrees. Is it because it's not suitable for cold weather?
Well, the thing with a thermostatic design steam trap is you have to know what the subcool is. And the subcool on some of the thermostatic design steam traps can be 80 degrees Fahrenheit, which will back up condensate and cause failure. And sometimes thermostatic design steam traps, people put them too close to the process, which can back up condensate in the process, which can generate water hammer. So the thing is that here's your benchmark. Any steam trap that's 250 psi or less should last you 15 years, period. If you have a steam trap failing within 15 years at 250 psi or less, there's something wrong. You have to understand, do root cause analysis, figure out what's causing the problem, and make the correction. But that's your rule of thumb, 15 years, period.
Okay. And how can we decide the percentage of leak from a steam trap?
Well, the thing is that, okay, so I set up a comparison method. And, depends on the ultrasonic units I'm using, 9,000, 10,000, is I come up with a comparison method and go to the discharge orifice. And the discharge orifice, the ultrasonic reading level would be X, okay? And anything higher than that is the degree of leakage. And now, when you wait for the steam trap to discharge, and I get X decibel reading out, and that point from my comparison method that's over that percentage of readout, it gives me my percentage of leakage through it. But actual flow is very difficult to do.
All right. Well, I think that did it for now. So everybody has Kelly's information here, and definitely you can be in touch with us as well if you've got further questions. So Kelly, thanks so much. I've got just a couple closing slides here. So as we kind of continue our month of anything and everything STEAM, next week we're going to have Adrian Messer from UE Systems come and do a webinar on how to create a STEAM report in our DMS software. So for those of you that are using our equipment and testing steam traps, he's going to show you how you can pull those reports and use DMS. So definitely come and join us for that one. We'll have an invite going out tomorrow so everybody can get the link for that. And then we're going to have Chris Colson from Allied Reliability come and do our final webinar at the end of the month. He's really good at all things energy and energy conservation, so we're looking forward to his presentation, and again we'll get an invite out for that next week. So just kind of continuing on with our STEAM month. Of course, if you've got other applications other than STEAM that are of interest, we do have 3 different online training courses available now. Our mechanical inspection and lubrication, compressed air survey, and electrical inspection, just really great online courses that can be taken whenever, wherever, and I don't know that it's going to be ready before the end of Steam-Timber, but certainly at the very beginning of October, we should be rolling out our STEAM online training course. So we're really excited about that, and you'll certainly be hearing more about that here soon. And thanks to Kelly, he was helping us with the content for that as well. So it should be a really, really good course. And again, you'll hear more from us soon. Definitely want everybody to stay connected with us. Hop on our LinkedIn groups, follow us on Twitter. Questions that you guys have had from today, those are good to toss out in a forum like our LinkedIn group, just to get feedback from other folks, how other people are writing their procedures, things that they've struggled with, things like that. I think those are great kind of community for sharing that kind of information. And then I'll leave our contact info up here. Again, I did record this, so we'll have that recording up later today, and everyone should see an invite for the DMS webinar tomorrow. If you don't get it, just shoot us an email and we'll be sure to get you signed up. But again, Kelly, thank you so much for taking some time out today, and thanks to everybody who joined us, and hopefully we'll see you all back here next week.
Thank you for having me. Have a great day.